Right. Here in the 18th question, right, the resistance of particular thermistor varies with temperature as shown. Right, here they have given the diagram. The student connected the thermistor in series with a battery and a resistor as shown. The resistor was made from a long length of wire. At a temperature of 45 Celsius, the resistance of the thermistor was 4 times the resistance of the resistor. Power P dissipated in the resistor was 0.38 volt. Derive the equation P equals V square over R. This is simple. Why? I will do it over here. Right? P equals VI. We know that. Right? P equals VI. And why P equals VI? It is equal to the uh, W over T. But yeah, this is enough, right? If you have written these things, you will get the marks. If you can check the marking scheme, they have given these steps, right? P equals VI. Then you have to use V equals IR. P equals IR and P equals VI. So what I'm going to do over here, right? So derive this one from one or two steps, we have to subject I, right? I is equal to V over R. Now you can place your uh, V over R instead of I in here. Then it is V over R. Then you will get what? V equals V square over R. Right? So for this point, I mean, using correct algebra for P equals VI and using V equals IR, you will get 1 mark, right? And for this one, 1 mark, right? Determine the potential difference across the battery, right? In this case, right, here they have mentioned what at a temperature of 45, right? What at a temperature of 45, right? But the resistance of the thermistor was 4 times the resistance of the resistor. That's a good point, right? If at 45, the resistance of the thermistor was 4 times the resistance, so it means here we have 4R and here we have R, and you know the potential difference across the battery is divided according to the ratio of R. So what you will have 4V if this is V, right? I hope you understand my point, because they have given this one, right? Now what I'm going to do, I'm going to calculate the uh, potential difference, right? For that I have to find the resistance of the thermistor at 45 degrees of Celsius. So here and here it is 50, right? And 35 is somewhere between here, and that is here. So it is nearly 35 ohm resistance, right? Okay, now I'm going to do my calculation. So the resistance of thermistor E, it is 35 ohm, and according to the data that they have given, the resistance of the wire, it is 35 over 4, because they have given the resistance of the thermistor is 4 times as the resistance of the resistor at 45 Celsius. So it is 35 ohm over 4. Then you will get 8.75 ohms for this, 8.75 ohms for this one. Then you can here they have given the power dissipated through the resistor, it is equal to 0.38 volts, right? Yeah, 0.38. And you know what, uh, P equals V square over R. Then you can find the voltage across the resistor by rearranging this equation. So V square is equal to what? P times R. So I'm going to take it from one step. So V is equal to what we call P is 0.38 watt times the R is 8.75 ohms, right? Okay, so if you calculate this one, what you will get over here is 1.82 volts. Then what about RT, right? You don't need to calculate it again. Why? It is 4 times this one, so it is 4 times 1.82 volts, and you don't need to calculate even this one. You can directly find the voltage potential difference across the battery, right? Potential difference across the battery. How? Right? It is equal, right, 5 times 1.82 volts. Why? Right here in the diagram, if it is 4 volts and if this is 1 volt, right, then this should be 5 volts, right? The 5 volts is distributed throughout the thermistor and the resistor, right? So it is 5 times 1.82 volts. So if you calculate this one, you will get 9.1 volts. So the potential difference is 9.1, right? For this one, they have given 4 marks, so you will get marks for dividing this one right over here. And you have to mention that 0.38 is the power, right? It is equal to v square over r. For using this one mark. And yeah, if it is not a show that question, so determine, so if your final answer is correct, you will get the full marks. You don't need to worry about your marks, right? If your final answer is correct, unless it is a show that question, right? Okay, explain why the resistance of a thermistor decreases as the temperature increases, right? It is easy. Why? Number of conduction electrons per unit volume increases. We increase the temperature, right? Then current will decrease. You have to mention that, right? So number of conduction electrons per unit volume increases, right? And what? So current increases, right? In the next question, here the student increased the temperature of both wire resistor and the thermistor from 80 degrees of Celsius to 90 degrees of Celsius. Explain why the current in the circuit decreased, right? Over here we have the what we call thermistor. It is thermistor, right? And here we have the resistor, right? So if you increase the current, sorry, if you increase the temperature, the resistance of the thermistor will decrease because it is increasing more number of electrons. But in this case, what will happen in the resistor, right? The resistance of the resistor will increase. Why? Because the atoms inside this resistor, they start to vibrate more frequently, so electrons cannot pass through uh, the resistor, so resistance of the resistor will increase, right? So if the total resistance is greater than the resistance, sorry, if the resistance of the resistor is greater than the resistance of the r t, which means the resistance of thermistor, then current will be decreased. So the condition should be r should be greater than r t, the resistance of the thermistor. Now we have to write this one, right? So what you have to write over here, right? Increased temperature, increased temperature, increased atom vibrations, or you can write lattice vibration or whatever you prefer. I'm writing as atom vibration, right? Then what will happen? This goes uh, and increase in the resistance, or you can tell it in collisions between electrons and the atoms, right? I hope you understand this one. If we draw the lattice or something like this, right? So when they are vibrating more frequently, what happened? Electrons cannot pass through between them, so the collisions of electrons and the atom increase, right? Because of this, resistance will increase. So resistance resistance of the wire increased, right? Ah, because the current decreases, total resistance of the circuit must increase, right? Here current is decreasing, so you have to mention that because current decreases, right, total resistance of the circuit must increase. Because current decreases, the total resistance resistance total resistance of the circuit must increase, right? And the last point, what should be it, right? The increase in the resistance of the wire resistor must be greater than the decrease in the resistor of thermistor, right? So you have to mention that one. So the increase in the resistance of the wire must be greater than must be greater than what, the decrease in the resistance of thermistor is in the resistance of the thermistor, right? If you don't know about lattice, I hope you have some idea about lattice. So you can imagine these are like atoms. Here we have atoms and they are connected by something like springs, right? They're not actually connected by springs. I hope you all understand that one. I'm try to give a kind of analogy for this one. Then they will bounce back and forth, right? I'm doing it for the x direction, but for in all these x, y and z direction, so they start to vibrate back and forth more frequently, right? So the electrons cannot pass through them, right? The collisions between electrons and the atoms will increase due to this vibration. Why they start to vibrate more frequently? Because of the internal kinetic energy. We are increasing the temperature, right? When we increase the temperature, right, the atoms, they start to vibrate more frequently because the internal kinetic energy is increased due to the increase in temperature, right?